In this section, we're going to find the values of these trig functions. And the first one we're going to look at is we're going to round to 4 decimal places, and we want to get the cosine of 25.98 degrees. Now, this is a calculator. In fact, this whole section is going to require the calculator. Now, I'm using a TI-84, and the first thing I'm going to do here is put my calculator into degree mode. There's 2 modes that you'll see on the calculator. One is degree, one is radian. We're going to be using the degree mode. For that degree key, press the mode key. Now the mode key is right next, it's up near the top next to the second key. So the second is the blue second. Just to the right it says mode. So don't press the second key, just press mode. When you press mode, you get this menu down here. The first is normal, the first is float, and then use your arrow key to make sure you're over here on degree. You want it to be in degree mode, so when you get it to degree mode, press enter and it'll highlight it. Then do a second quit. And the quit, well, the quit key is right above the mode, so you press, now you press second and quit. So press second, mode, and it'll quit. Not quiet, it'll quit. Then you're back ready to compute. So let's do it. Press the key that's got COS on it. It's kind of in the middle, just slightly above the middle, COS. And when you do that, you're going to get this. Here's what you get. You get COS and a parentheses. Now, in the parentheses, now you're going to type 25.98, and then you can close the parentheses, and the closed parentheses is right above the 9. So you'll type 25.98, close. And when you do that, here's what I got. I got 0.89894, dot, dot, dot. But remember what we're going to do. Up here, we're going to round to 4 decimal places. That's pretty common. So we'll write our conclusion now as 0.8989. So now in number 2, we're going to find the tangent of 30.1 degrees. So what we're going to do here is we're going to press the tangent key. Now the tangent key is just to the right of the cosine key. So we're going to press the tangent key. And when you do that, what comes up is tangent with a parentheses. And now type into 30.1 and then close the parentheses. So type into 30.1, close the parentheses, and I'm getting this, 0.57967, dot, 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 but rounding to 4 decimal places, right? 1, 2, 3, 4, we're going to round that up. So we're going to say then that the tangent of 30.1 degrees is 0.5797, rounding up. Now we're going to try to get the secant of 57.3 degrees. But if you look at your calculator, there is no secant on there. You have sine, cosine, and tangent, and then above them you have some other trig functions, but we don't have secant. So we're going to have to derive this. So what we'll do is this. I'll derive this one. We'll do this one together, and then we'll just list all the relationships between the trig functions. So here's the definition of all of our trig functions. Now here's where I'm going to start. So I'm going to start here with the cosine of angle A, and what we know is this, that the cosine, right, here's our definition, is the side adjacent over the hypotenuse. So let's write that. Let's write side adjacent over hypotenuse. Now what I'm going to do is take the reciprocal of each one of these. So before we actually do that, let's just get a little reminder of what reciprocal is. So if you have a number like 5, the reciprocal is 1 over 5. If you have a number like 2/3, reciprocal you get just by flipping it over. 3/2. If you have a number, say an expression like xy, the reciprocal is just y over x. So what I'm going to do here is take the reciprocal of both sides. So I'll get 1 over the cosine of angle A, and that's going to equal, now, just like we did over here, if you have a fraction, to get the reciprocal, you just flip it over. So all we're going to do is just flip this over, and that will give us hypotenuse over side adjacent. Well, now look at this. What is the hypotenuse over the side adjacent? If you follow it down here, here it is. The hypotenuse over the side adjacent, that happens to be the secant of A. So where we are now is this. 1 over the cosine of A is the same as the secant of A. Or we're going to write it like this. How about if we write it like this? The secant of angle A is 1 over the cosine of angle A. Now, the cosine is on our calculator. The secant is not. So if we need the secant, we're just going to type in 1 divided by and then write the cosine. So let's actually do it for this problem. What we're looking for here is the secant of 57.8 degrees. So we know that this is going to be 1 over the cosine of 57.8 degrees. And this, on my calculator, now here's what I did. Here's what I typed in on my calculator. I just typed in what I'm seeing here. I typed in 1 divided by, I pressed the cosine key, that gave me a parentheses. I typed in 57.8 and closed the parentheses right above the 9, and that gave me 1.8766, I'll round to 4 decimal places. So now I've got that the secant of 57.8 degrees is 1.8766. So let's just summarize them all. We did this one here, right? We derived this one together, that the secant of some angle A is 1 over the cosine of that angle A. Now here's another one. We did not derive this, but you could the same way we did the secant. The cosecant of an angle A is 1 over the sine of angle A, and that the cotangent of angle A is equal to 1 over the tangent of angle A. And this brings up this idea of cofunctions. Notice that these are cofunctions. I got an S and a C, they go together. The S and the C go together. So I'm not going to get these mixed up. The secant goes with the cosine, S and C. Cosecant goes with the sine, S and C. I'm not going to think secant and sine because I'd have 2 S's and no S and C. Now number 5, this one's pretty straightforward. This is the sine, and the sine is on the calculator. So what I'm going to type in on my calculator, I'm going to press the sine key, and when I do that, I get a parentheses. I'm going to put in 62, close the parentheses, and when I press equal, I'm going to round off to 4 decimal places. I get 0.8829. So what this is saying is this. If we have an angle of 62 degrees, okay, in a right triangle here, let me draw that a little bit better. All right, what is the sine of that 62 degree angle? It is 0.8829. Now this problem's a little bit different. We're given the sine of some angle is this number right here, and we want to go backwards and get the angle. Right now, if you look at your calculator here, what you're going to see is a key that looks like this. You're going to see the sine key. It'll say sine, and then right above it you'll see sine inverse. And the way to read this is the inverse sine, or you can read it as the angle whose sine is, okay, so the angle whose sine. So what we're going to do is just press that key. So we're going to press the inverse sine key. You have to press second first, right? So you press the second key, and then the inverse sine, and you get a set of parentheses. Then you put in 0.6382, and when you do that, 0.6382, I'll do it too, I'm getting 39.65, and the book is telling us to round this off to 1 decimal place, so that's a 5, so we'll go up. So how about 39.7 degrees? Now, here's the way that I read that. I would say this: the angle whose sine is 0.6382. That's how I would read that. And then I could even go further and say is 39.7 degrees. But that is how we're going to read that inverse sine. The angle whose sine is, and then that number. Now we would like to get the angle whose secant is 1.233. Now, we're going to write something here, but just let me show you why it works. Here's what we do know. We know that the secant, right, we derive this one, that the secant here is 1 over the cosine of the angle. So that's going to be 1.233, right? These two things here are the same. Secant of theta, 1 over the cosine of theta. They're identical. Now, if we multiply, see if we can do it, multiply by cosine of theta, here's what we get. 1 is equal to 1.233 times the cosine of theta. Now the cosine is on our calculator, so we can work with this one. So let's get the cosine isolated. So what we're going to do here is divide by this 1.233. Let's divide by this. So we'll get, I'm going to write it this way. Cosine theta is 1 over 1.233. So now what I want to do is I want to get the angle. So I've taken it from secant, which I don't have on the calculator, to a cosine, which I do have on the calculator. Now, if you look right above the cosine key, you're going to see a second key. So what you want to do is you want to press second, and then, okay, let me see if I can get it here. What we're going to do is we're going to press second, and then we'll press the cosine key. And what that does, that's going to give us the inverse cosine, and then a parentheses. And what we want here is to type in this. So let's do that. So we'll type in 1 divided by 1.233, and when we do that, all right, well, I got 35, I'm going to round off here, I got 35.80, so I got this, I got 35.80 dot dot dot. So the book says just round it off to a tenth, so I'm going to round off here. So I'm going to round this to 35.8 degrees. So just quickly, if you're given one of these trig functions that is not on your calculator, like suppose, let's just do another one. Suppose we have cosecant. So how about if we had this one? What if we have the cosecant of some angle is 1.4945 degrees? We don't have to go through all this, but we could. But here's what we can do. We know that the cosecant is related to the sine. So what we can type in here is we could just press second and then the sine key. Now when we do that, we're going to get the inverse sine, but then it would be 1 divided by that 1.4945. And when I did that, I got 41.999. If I round off, how about 42 degrees? Right, so what you need here is you need that inverse function that's on the calculator, and then 1 divided by the angle that you're given. Let's try another one here. So we've got the cotangent of some angle is 1.351, but we don't have cotangent. So what we can do is we know that cotangent is related to tangent. So what we're going to type in here will be a second, right? So type in, press that second key, and then press the tangent key because that's what's related to it, and we will get this. What comes up is the inverse tangent, parentheses, and now type 1 divided by 1.351. And when I did that, I got 36.508 dot dot dot. So how about if we just say theta is 36.5 degrees? So here's what's going on in this problem. Say there's a car going up this grade. Here's the ground. And there's a car going up this grade, and it has a certain weight. And for us, this grade is 1.6 degrees. Well, there's a certain resistance to it. There's some force coming down like this resisting the travel. And that's given by F equals W, the weight of the car, times the sine of A, the angle. Now what we know in this problem is that we want to find the grade resistance, I'm supposed to say resistance, of this car here, and what we've got is F equals 2,900, it weighs 2,900, times the sine of that 1.6. So on our calculator, we're going to type in 2900. We'll press the sine key, and then we'll type in 1.6, right? So it's going to look like this. 2900 sine parentheses 1.6, and then if we just round to one decimal place, I'm getting 80.97, so on. Here's what I'm getting, 80.97 dot dot dot. I'm just going to say it's this. It's 81 pounds. In problem 10 here, the last problem we're going to do, this has to do with the study of optics. And suppose now that this is a light ray in air, like a light beam. You have a light beam coming down here, and it hits the surface of glass. Well, the glass is more dense than the air, so the light is bent. You've probably seen this in water, right? You look at a reflection, and it seems to be bent. So this I is called the angle of incidence, and this is the angle of reflection to this line perpendicular. So you have this perpendicular line here, so just imagine you're doing this. So there's a line that's parallel to, you're standing up, here's a line parallel to you. A light ray comes in and hits the surface of that glass, and then it gets bent. Now it comes in at this angle here, and it gets bent to now this angle here. Now we're going to let this lowercase n equal the index of refraction. It's just a measure of what kind of refraction we get, not reflection. Reflection would look like this. It reflects. Refraction is when it does just what this is doing here. That's refraction. So n is going to be a measure of that amount of refraction. And here's a formula for this. So we can get the index of refraction by making this division. We'll take the sine of the angle of incidence and divide it by the sine of the angle of refraction. So in this problem, suppose that we have this. This angle here of incidence is coming in at 49.9 degrees. And the angle of refraction here is 34.7. So let's find n, the index of refraction. So we're just going to put these numbers in now. We'll get n is equal to the sine of 49.9 degrees divided by the sine of 34.7 degrees. And I'm going to type it in just like this. I'll press the sine key, parentheses, 49.9, close the parentheses right above the 9 key. Divide, press the sine key, type in 34.7, close it with the parentheses right above the 9. And when I did that, I'm going to round to two decimal places. I got this. I got that n is equal to 1.34 dot dot dot. So I'll just round off to two decimal places, 1.34.